Is C++ difficult to learn? Does it require much more time in learning C++ than in learning other languages? Is there any way to avoid wasting time in learning C++? In this video, I will give you a simple table to show you what's the C++ content you should not learn in year 2023, and the top 4 mistakes that you should avoid to speed up your C++ learning experience and make the learning much simpler. Let's dive in. My first C++ program is a stock analysis program, and that was 20 years ago. What surprises me is that even after 20 years, there are still so many bad advices flowing around the internet. There are 4 worst advices you can hear on internet in terms of learning C++. Number 1, learn C before learning C++ because C is a subset of C++, is simpler, therefore it gives you a better learning curve or shorter learning curve in learning C++. This is probably the worst advice you can hear from learning C++. There's 3 reasons. Number 1, it's against the whole purpose of why C++ should replace C, which is raise the abstraction level in plain English, make it simpler writing code. C forces you to pay much attention on the low-level details. For example, how to allocate memory, how to manipulate pointers, and so on and so forth. These don't give you the productivity. What C++ trying to promote is, no, you need to think at a high level. You just think your business logic and let the compiler and the operation system to do the work that is supposed to closer to the machine. For example, you should not think about pointer. You should think at the level of array, list, and even at a higher level. That can save you a lot of time. That's why C++ includes so many ideas such as object-oriented programming, templates, standard library, and so on and so forth. And you might think, I just want my program to be most efficient and the fastest one. And still, this is the second reason why learning C is a bad idea. Is because against the most common conception, C is slower than C++. And the third reason why learning C before C++ is a bad idea is that you waste so much time and gaining so little. See, C++ has 4 pillars: C, object-oriented programming, template, and standard library. And the C part is purely designed to backward compatible with C back in 1980s. That was a very good marketing strategy because back then, 40 years ago, most programs love C, and because C++ was backward compatible, any C programmer would think, and my program, because it's a subset of C++, it can simply compile it by C++ compiler. So I have no issue to port my program into C++. That was a great decision, and that was one of the biggest reasons why C++ became so popular. But the problem is, now it's the year 2023. If you don't have the need, which I suspect it's true, to backward compatible with C, why bother? And because the 2 previous reasons is slower and it's at lower abstraction level, why are you wasting time learning the C features? Why don't you start straight from the C++ core concept? And that can save you a lot of time. Speaking about the C++ core concept, let's go back to this table, those 4 components. We talk about the C, and we haven't talked about the other 3 components. That's a great segue to the second worst advices in learning C++, which is learn object-oriented programming. I know this is controversial, and object-oriented programming has its good part, which is the concept of class, which helps you to hide internal information and only expose the proper information you want the outside module to know. That's a good part. The bad part of OOP comes to its very popular concept of inheritance. The inheritance concept allows you to define a parent class, say animal, and within which you can define a function called run. And then later on, you define a child class which inherits from animal. Automatically, dog will inherit the function of run. In this example, we write the main function, and within that we claim animal and dog, two objects. And then we can run animals run. And then you know what? You can write dog run. And let's see what's the result of this function. Let's compile it. And let's run it. See, you have two animal runs, which means that the dog's run function is exactly the same as animal's run function because they are the same function. And the dog can even define its own run function. So let's see, let the dog's run function print out the dog's run. And then let's run the exact same code. Let the animal and dog both run and to see what the output is. So we compile and then we just run it. Now you can see it's print out the animal run and dog run because now dog has its own function, so it prints out its own run function. So far, so good. But this is not very useful. A much more useful scenario is that if we define a function, let's name it call run, and let's pass an animal object to it, and within which we just call animals run. And what we want to do is to, when we pass the animal to call run, it will print out animal. And if we pass dog to call run will call dog's run function and print out the dog run. This scenario is the foundation of many design patterns. So it's very important for C++ to support it. And let's call the call run. The first time we pass animal and the second time we pass dog. Let's see how it behaves, and we compile it. And let's run it. But you can see it prints out two animal run, which means that no matter what object you pass to call run, it always prints out the animal's version of run. This is not what we want. The way C++ to resolve this issue is to add a virtual keyword to declare the run function as a virtual function. Once a function becomes a virtual function, you can switch the type dynamically. And let's run the same function and see what the result is now. So now it prints out the animal run and the dog run properly. I hope so far you are still not confused. If you are not, congratulations, you are the top 5% of the first-time learner. 95% of people, when the first time hear the virtual function and overload, this kind of concept, they get lost. That leads to the first downfall of the OOP inheritance, which is, it's very confusing for many people. You need to understand the virtual function. You need to understand the two versions of run for dog and for animal, when to call which. This industry has a much better solution, which we will talk about later. So that's the first point I'm trying to make, is that it's all not necessary to use virtual function and OOP concept to resolve this issue, because we have a much simpler solution, which we will explain later. If it's just confusing, it's not a big problem. However, inheritance have a much bigger problem. Let's see this example. So now we have a third class called cat, and this class is not done by ourselves. It's written by other teams or even previously, and it has a run function, and it prints out the cat run message. And in this case, because cat doesn't inherit from animal, you cannot pass cat to call run function. And this causes a big trouble. The best example to demonstrate this issue is the early version of C++ libraries. In the early version, if they want to just implement 1+1, this function, their object library will have to invent integer class, floating class, so on and so forth. And for each class, they will have to define plus, minus, set, and get all those functions. And you may ask why? Doesn't C++ already provide the function that you can add integer together or you can add floating types together? Yes, but this is precisely where the problem is. The object library, which purely rely on inheritance, because it doesn't inherit from integer, or the integer data type doesn't inherit from the object tree, you cannot pass integer type to a function except class parameters. Let's demonstrate this with code. Say if you have an add function which accepts two objects, and then you do some calculation inside. For this function, it cannot accept integer type as its parameters because integer doesn't inherit it from T object, and vice versa. So that's the reason why the early C++ library, they will have to come up with the integer object to accomplish the very simple thing 1 plus 1. This design is very convoluted. You have to put tons of efforts to reinvent the wheels, which have been done by those simple data types. That's why the industry came up with a much better solution. We call it generic programming, or some people call it template-based programming. That leads to the third biggest problem: fail to learn generic programming at the beginning. By bypassing the inheritance concept and learn generic programming can save you tons of time of learning C++, and your code structure will be much simpler. And the modern version of C++ library, which we call it standard library, completely abandoned the OOP concept. They use something we call template-based programming or generic programming, where we use these two concepts interchangeably because they mean the same thing. That actually leads to the fourth biggest mistake in learning C++ in year 2023, which is fail to learn the STL, the standard library, right away. The STL provides tons of functions that you can use right away. It can not only save you time, but make your code much, much simpler. To sum up, if you take a look at this table, get rid of the C part, avoid learning the inheritance part of OOP, and start right away in learning template-based design and STL. That can not only save you tons of time, but make your code much simpler. By the way, one bonus point, don't ever use pointers in C++. Java doesn't have this concept, and you don't need that in C++. If you like this video, please share and subscribe and like. Thank you.